Right, so here we have a Leaving Cert sample question on probability and statistics. And this is looking at inferential statistics. It's looking at confidence intervals for means. Now in these questions, hard to know what they're always asking you. So my best advice would be to label each part of the question, label each figure they give you, then go to page 34 of your table, and if it's a confidence interval, it's either going to be the confidence interval of the mean or the confidence interval of the proportion. And at Leaving Cert level, they're based at 95%, and 95% corresponds to a Z-score of 1.96. Right, so in this question, question 1, a survey of 50 Leaving Cert candidates. So that 50 stands for N, it's the number of students. Randomly selected the Dublin region, found they had a mean mark. So they had a mean mark, they being that sample, had a mean mark of 374. So the mean of the sample is X with a little cap. The standard deviation of the sample is 45. Find the 95% confidence interval for the mean. So as I said, there are going to be two confidence intervals, either one for the mean or one for the proportion. This one's for the mean. So we're going to have an estimate of the population mean from the sample mean itself, and then interpret this interval. So 95%, that's your 1.96. So what you do is X bar minus 1.96, the standard error of the mean, as we can see here, is standard deviation over root n. We're going to get an estimate of the population mean, so U X bar plus. So plus the margin of error either side, plus or minus the margin of error. This is based on your normal distribution, your central limit theorem, how far away it is. These are your intervals. This is your margin of error here and here. So this is the lower side, your minus 1.96. This is your upper end of the interval, the plus 1.96. And now all you've got to do, sub it into this. So X bar 374 minus 1.96, standard deviation 45 over root 50, and then do the same the other side. Standard deviation 45 over root 50, and lob that into your calculator, and you'll get your two endpoints then. .361.53. So as we can see, it's lower than the mean mark here. Don't delete it, just go back, make your minus b formula, delete the minus at the plus, and 386.47. Population mean, when it says interpret, the population mean, which is U, as we put it here, lies in this interval 95% of the time. If we wanted a 98% confidence interval or a 99% confidence interval, this will have a wider range, be a bigger margin of error from here. And if we had a smaller confidence interval, say a 90% interval, this population mean will lie in this here interval a smaller amount of time, so a smaller range, I should say. Part B, the mean mark in the subject for all Leaving Cert candidates in 2014 was 385. So for all Leaving Cert candidates, so this is your mu, your population mean. Standard deviation is 45. John suggests the mean mark in the Dublin region is not the same as the whole country. Test this hypothesis using a 5% level of significance. That just means a 95% confidence interval. It's the exact same, don't let that put you off. Clearly state your null hypothesis, your alternative hypothesis, and your conclusion. So starting off with your null hypothesis HO is statement of no change. So you could just write U is equal to 385. Or if you want to put words, the mean of the population is 385. So statement of no change, it is whatever it states. And your alternative hypotheses, H1, HA, whatever you want to call it, U is not equal to 385. That implies the mean. That means the mean of the population is not equal to 385. So in this one here, we're going to be looking at getting our Z-scores using this formula here because they give us the size of the sample, and then we're going to find out if it's in the critical regions. So in the critical regions, if it's bigger than 1.96 or if it's got a Z value less than minus 1.96. So 5% level of significance, critical regions, or Z bigger than 1.96 or Z less than minus 1.96. Again, that just goes back to your normal distribution with your mean up here. So that's what we're looking at. Bigger than 1.96, everything over this here region. We'll get onto p values later, so your p will have a low, your probability will be less than 0.5, and here minus 1.96. So if it's in any of these two regions, we reject the null hypothesis. And if we're in this here region here, we fail to reject. So we never accept, we fail to reject. And then here, or we never accept, we either fail to reject, and out here we're going to reject the null hypothesis. So depending on what value we get. And then fill in all your values. So your x cap is 374 minus population mean 385, standard deviation set up there is 45, and then n is your sample size, as you see up here, is 50. Is 1.73. So if we're looking at our little sketch over here, minus 1.73 somewhere in this region, so it's not in either of the two critical regions, and as a result of that there, we can only fail to reject the null hypothesis. So the mean of the population is still 385. It's bigger than minus 1.96. Doesn't lie in the critical region. We fail to reject the null hypothesis, HO. So the mean of the population isn't any different in the Dublin region to the rest of the country. And that's that question done. We'll do a few more. If you have any questions, just leave a comment below.